Hi guys, welcome back to my channel. If you're new, please like and subscribe to my channel. In today's videos, we're gonna talk about why is my BMW running rough? Why is my BMW have poor performance problems and misfire problems. Today we're gonna figure out, give some ideas of where to look if you're having problems, if you try to fix different things and the problems still exist. Pretty much give us some ideas where to look to solve your problems. Okay, let's go. If your BMW is having a rough idle, the first place you want to look is check the mass airflow sensor. The mass airflow sensor, the MAF, is one of the key components of an electronic fluid injection system in your car. It is installed between the air filter and the intake manifold of the engine. The mass airflow sensor measures the amount of air entering the engine or the air flow. A contaminated or fault mass airflow sensor cannot measure the amount of air flow correctly. This causes the engine computer to miscalculate the amount of injected fuel. As a result, a bad mass airflow sensor causes various drivability problems, include a no start, stalling, lack of power, poor acceleration. A faulty mass airflow sensor might cause a check engine or service engine soon light to come on. Sometimes the mass airflow sensor will not throw a fault code, but if there's a fault code, here are some of the codes you should look for. P0101 mass airflow circuit range / performance. P0102 mass airflow circuit low. P0103 mass airflow circuit high. P0104 mass airflow circuit intermittent. There are also other trouble codes. P0171 system 2 lean bank 1 and P0174 system 2 lean bank 2. Often mass airflow sensor reading are measured at idle 1000 RPM, 2000 RPM and 3000 RPM. A contaminated or bad airflow sensor will in most cases show lower airflow reading than a known good one. In some cases a bad sensor may show higher readings. Different engines will have different reading. The airflow depends on the engine volume, so a V6 or V8 engine will have higher reading. Low mass airflow reading do not mean the sensor is bad. A clogged up air filter or plug catalytic converter can also cause lower airflow sensor reading. What causes the mass airflow sensor to fail? Dirt accumulation, too many miles on the sensor, water damage through the air filter, airflow flowing back out of the crankcase ventilation, bad connector or electrical wires. Next, check the manifold absolute pressure MAP sensor if you are still having rough idle issues. Manifold absolute pressure sensor, commonly known as MAP, is a part of an engine electronics regulatory system. The main purpose of this sensor is to create optimum combustion in the engine. Sometimes, due to the faulty manifold pressure sensor, fuel control activity gets disturbed. It affects the overall performance of the engine. Therefore, in order to detect such issues at an early stage, it is important to consider the bad MAP sensor symptoms. Manifold pressure sensor, which means it calculates the pressure inside the manifold. In detail, the main work of this sensor is to provide manifold pressure information to the PCM. The powertrain control module uses this data to determine the amount of fuel injection in the cylinders. It is also helpful in controlling the ignition timing, which further prevents sparks and thus protects the engine from any damage. A faulty or bad MAP sensors also cause increased emissions from the vehicle. When the manifold absolute sensor signal the high load of the engine to the PCM, it increases the release of fuel into the cylinders, because of which the economy of the fluid reduces. Some of the key problems you should look for when a MAP sensor is faulty or bad is poor fuel economy, lack of power, fail emissions inspection, rough idle, hard starting, hesitance or stalling, check engine light, and low engine vacuum. Common manifold absolute pressure MAP sensor fault codes are as follows: P0068, P0069, P0105, P0106, P0107, P0108, P0109, P1106, and P1107. Okay guys, let's talk about misfires. So if you're having misfires, the first place you want to check is the ignition coils. The purpose of an ignition coil is to convert the low current from a car battery into enough power to ignite the fuel and start the engine. When there is a problem with an ignition coil, it will cause a range of mechanical and performance issues. Some of the problems you will encounter when your ignition coil is faulty or bad or engine misfires, rough idle, decrease in car power, especially in acceleration, poor fuel economy, difficulty starting the engine, check engine light is on, exhaust backfiring, and increased hydrocarbon emissions. Next, check your spark plugs if you're still having misfire issues. Spark plug emits a bolt of electricity across a small gap, igniting the fuel and air mixture that puts the pistons in motion and gets your vehicle up and running. It's a critical job that spark plug have, because if they are worn out, they won't emit a spark and start your car, or can even cause significant damage. Effects of failing spark plugs or bad spark plugs: reduced gas mileage, lack of acceleration, hard starts, engine misfires, rough idling. Next, check your high pressure fuel pump if you're still having misfires or performance problem with your car. The high pressure fuel pump is a piece of machinery responsible for injecting fuel into the combustion chamber of your engine, which allows your car to run more efficiently. Due to the way the engine is built, failure of the fuel pump means no fuel in the engine. Symptoms of a high pressure fuel pump failures are delayed start of the engine, hesitation or spurting in acceleration between 2000 RPM to 4000 RPM, high engine temperatures, vehicle stalling due to exertion or temperature, fuel pressure gauge reading low measurements, poor gas mileage, engine misfires. Here are some of the reasons why your car high pressure fuel pump fails: leaks in the injector pump, poor quality of oil, lack of regular oil change, solenoid failure. Next, check your O2 oxygen sensors. Modern vehicles have an upstream and a downstream O2 sensor. Upstream O2 sensors are located before the catalytic converter, while downstream sensors are located after the converter. What are the signs an O2 sensor may have gone bad? Check engine light comes on, noticeable loss of fuel efficiency, sulfur or rotten egg smell from exhaust, black smoke from exhaust, emission level reach high levels. Your engine hesitates, skip, begins bucking, or has power surges. What causes an oxygen sensor to fail? Sometimes O2 sensors simply fail due to time and miles. In other cases, an O2 sensors may go bad due to contamination from substances such as oil, ash, and coolant. Environmental factors, example water and road salt, can also cause an O2 sensor to fail. Next, check your BMW secondary air pump and your BMW secondary air injection control valve. Your BMW secondary air pump and your BMW secondary air injection control valve works together. Immediately following a cold engine start, injection of ambient air from the engine bay is directed to each exhaust manifold through a one-way valve. Due to this burst of air, hydrocarbons will oxidate quickly until the catalytic converter warms up. This will result in cleaner emissions on cold starts, where vehicles usually run rich due to unburned fuel. The BMW secondary air injection control valve regulates the flow of air from the air pump. This valve is attached on the side of the cylinder head just in front of the forward exhaust manifold. It is designed to regulate the flow of air from the air pump into the cylinder head. Symptoms of the failing BMW secondary air pump: noisy/faulty bearings inside the pump, cracked, broken, dry, rotten vacuum line, cracked, broken, dry, rotted air supply line, clogged one-way valve due to carbon buildup, misfires, led to power loss, idling issues, or stalling during cold start. Pump failure will also affect the emissions output of your vehicle. BMW secondary air injection control valve failures: check engine light, failed catalytic converter, failed emissions test, low idle, sluggish acceleration, misfires, and engine stalls. BMW secondary air injection control valve fault codes: fault codes P0492, P0410, P0411, P0412. Faulty one-way check valve most commonly fails in cold weather. Intake leak, faulty relay, blown air injection pump fuse, faulty secondary air pressure sensor, clogged secondary air injection ports in the cylinder head, vacuum leaks. Next, check your BMW non-return check valve. This oil check valve is located on the side of the cylinder head and helps keep oil on top of the engine in the cylinder head. BMW cylinder head non-return check valve keeps oil from draining out of the valve train and Venus system after shutdown. Over time, these can become clogged, particularly if long change intervals are followed, allowing oil to drain out of the upper internal passageway. This can contribute to the notorious startup rattle and result in premature Venus and valve train wear due to poor lubrication during startup. BMW cylinder head non-return check valve failures: lack of oil being in the cylinder head can cause P0012 and P0015 codes. P0012 fault codes: engine oil is too low, dirty/sludge engine oil, low oil pressure, malfunctioning camshaft timing, short in intake timing control/oil control circuit, faulty intake valve timing control solenoid, faulty oil control valve. Other codes such as misfire codes: P0300, P0308, P0015 fault code. Powertrain control module or PCM detects that your vehicle's camshaft timing is over retarded. Finally, check your BMW engine variable valve timing solenoid, aka Venus. If you're having major misfires in all cylinders, poor and rough idle issues, hesitation or limp mode under acceleration. The Venus system that you likely have in your BMW uses oil pressure to control the position of the intake and exhaust camshafts using a gear on the Venus actuator and on the camshaft. A long coil of wire wrapped several times, called a solenoid, controls the amount of oil pressure that is applied. The Venus systems comes in either two pairs or one pair, which include an intake Venus solenoid and an exhaust Venus solenoid. The intake Venus solenoid is on top. The exhaust Venus solenoid sits on the bottom. Your Venus solenoids comes in either one pair or two pairs. It depends on if your BMW has a single Venus system or a dual Venus system. A single Venus is the original design first seen on the M50 engine back in 1992. It's called single Venus because it only features the Venus system on the intake cam. Double Venus system adjusts the timing of the intake and exhaust camshafts with continuously variable adjustments based on engine speed and throttle opening. Double Venus is associated with a Voltronic system. Voltronic is a system that controls how far the valves can open at any given time, compares to Voltronics controlling when they will open. BMW has introduced this solution in an effort to improve efficiency, but also get rid of the standard throttle body design. With Voltronic, you don't need to control how much air enters the engine on the intake. Instead, you can simply control how far the intake valves open. What BMWs use a single Venus system? These BMWs are the M50 engines from 93 to 2000, the M52 engines from 93 to 2000, S52 engines from 93 to 2000, M62 V8 engines from 93 to 2003. What BMW used dual Venus and Voltronics? N52 engines from 2004 to 2010, N55 engines from 2009 to present, N62 engines from 04 to 2010, N73 and N74 engines from 2005 to 2015. Single Venus failure symptoms are as follows: loss of drivability, decreased horsepower and torque, rough idling and sometimes a rattling noise, poor fuel economy. Single Venus engine fault codes: P1519, BMW 2120XD4. This pretty much says that the Venus system is getting stuck and jamming up. Dual Venus failure symptoms include loss of torque and power in the lower range, hesitation or slow reaction time when you press the pedal, idle ECOPS or a constant rough idle, slow cold starts, limp mode after acceleration. Dual Venus engine fault codes includes P1520, P1523, P1397, 2882, 2887. Dual Venus with Voltronics failure symptoms include poor and rough idling, loss of lower range power, cold start issues and noises, engine stalling at idle, hesitation or limp mode under acceleration. Dual Venus with Voltronic engine fault codes includes P0011, P0012, P0020, P0014, P0015, P0020. Dual Venus with Voltronics engine fault codes continues such as P0021, P0022, P0024, P0025, 2A7A, 2A99, 2A87, 2A82. A faulty or failing Venus can create a lot of problems, especially in the cylinder head, because lack of oil getting into the cylinder head can lead to other issues, which I'll explain in the next segment of the video. Okay, so the main reason for major misfires on all cylinder in your engines, and poor performance and rough idle issues is due to your BMW cylinder head hydraulic valve lifters are lacking major lubrications. Hydraulic lifters consist of a cylindrical body with an internal piston that protrudes from the top. A lifter is a cylinder that sits between a car camshaft and the cylinder valves. As the camshaft moves over the top of the lifter, it actuates temporarily opening the valve. And because the intake and exhaust valve need to be open at different times, each has its own separate lifters. When the cam presses down on the lifter's piston, it closes the channel. This locks the valve open temporarily, even under high pressure, so that gas can escape the cylinder. Pressurized oil enters through a hole in the lifter's body and flows into a narrow channel. This oil enters the internal lifter cylinder but flows freely out of the other side. When the cam passes its apex, the lifter pistons can rise, allowing the oil to flow freely again. In turn, it causes the valve to snap shut, preserving proper engine air pressure. It's very important that your cylinder head, oil check valves, and your intake venous solenoid and exhaust venous solenoid are in perfect working order, so oil can get through the oil lines into the cylinder head so the lifters can be lubricated. Faulty hydraulic valve lifters may occur due to the following: a sticking check valve, lifter spacing issues, lifter wear or dirt in the system, lack of lubrication or dirty engine oil, high vehicle mileage, irregular oil servicing, not using the correct engine oil, clog/faulty engine oil filter, faulty cylinder head check valves, faulty intake/exhaust venous solenoids. Symptoms of a bad hydraulic valve lifters include the following: excessive engine noise, engine misfires, broken push rods and dead cylinders, check engine light, rough idle issues, poor performance issues. Okay guys, in this video I have highlighted and explained in details all the possibilities why your BMW may be having major engine misfires, rough idle issues and poor performance issues. Just go through the video. Chances are there's one of these items that is affecting your BMW as to why it's behaving the way it does.